Good day, everyone. Today we are discussing the unit circle and the Pythagorean. So usually in these videos, I go with the announcements, tell you what's going on next, and then I dive into the lesson. So what I think I'm going to do for the sake of time when I make these videos is dive straight into the lesson instead of the announcement side of that, because that could be done in the classroom. All right. So your learning objective is using the trig ratios to create the outer part of the unit circle, but we're also going to work on the inner part of it. So that standard of this says display how the unit circle in the coordinate plane enable the extension of trigonometric ratios to all real numbers, interpreted as radian measures of angles transverse counterclockwise around the unit circle. That is a lot that's going on in that. So this is going to be a 6-part lesson. All right, we spent a lot of time with the Pythagorean and a lot of the trig ratio. So now we're ready to go into the unit circle. But first, this definition, the precise definition of mathematics. So this is a critical definition because in life we use mathematics as techniques to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. So it doesn't matter who you are or what you do, you satisfy this precise definition of mathematics by the majority of this vocabulary. Now, counting. Everybody counts, everyone measures, everyone classifies. We all orders and we infer. So the definition of to infer, like an inference, and modern patterns arising in the environment. So the only thing that we don't do too often day to day is cipher. Now some of us, will, you know, cipher, but most people do not cipher. This is critical. You have to know this definition. You're going to see it, so make sure you know it. All right. So we spent a couple of days now with the right triangles, and we, got it down to a science. So we're going to move on. But let's touch it right quick though. So we know for a 30-60 triangle, your hypotenuse is going to be 2 times your short leg, and your long leg is going to be your short leg times the square root of 3. For the 45-45 degree triangle, the legs are equivalent to each other. And the hypotenuse is going to be 2 times, I mean, it's going to be the short leg times the square root of 2. And here we go again, but it's just a little bit easier to understand. Again, you guys, we have learned this for days in, so we moving on because we're going to add more to it. You're going to see how these special triangles play into today's lesson. All right, so we are trying to build a unit circle. The goal is to build the outside of it, but we have to go into the unit circle from the inside. Now, I want you guys to pay close attention to how it's color coded, because the color coded is going to tell you exactly what's up. That's going to visually help us with today's lesson. All right, circles and Pythagorean, because we have to know all about it. So, a circle is the set of all points on a plane that are a fixed distance from a center. This is a critical definition because the unit circle is going to build all on this, and you're going to realize that the Pythagorean theorem is not for the triangle, it originates from the circle. The Pythagorean theorem originates from the circles. All right, so what you see right here, this is the equation of a circle. There's the equation from the circle. H and K is the center, the R is your radius, X and Y is just your outer point. So we need to make sure that we have a good understanding of this being a circle, equation of a circle. And we're going to see how it plays into the Pythagorean. So you are going to have to prove the Pythagorean theorem. So to do that, in regards to using the knowledge of the circle, you have to start your proof as letting x and y represent any point on a circle with a center at the origin and the radius is 1. Using the circle equation, which is that's what we're working with, and we are trying to show the Pythagorean theorem from the equation of a circle. So the center, which is the point H and K, that is going to be at the origin. So H is 0, Y is 0. K is 0. And when you get that, you get x squared plus y squared equals 1 squared. Sounds like a squared plus b squared equals c squared to me. And from there we know that y squared is just 1. But we got to take the square root of both sides to get things situated. Well, actually, not the square root of both sides, just the square root of, well, yeah, it's square root of both sides. Because we know that the square root of 1 is just simply just 1. So x plus y equals 1, which is equivalent to a squared plus b squared equals c squared. Therefore, you prove the Pythagorean theorem using the knowledge of the circle. Now, if you can see the image right here, you see how we got the Pythagorean theorem, how it came to be. Because it just came from the triangle. So, your radius from the center to the most outer point is going to be your radius, the distance between the 2 points. And x and y is that distance from from the furthest out of the circle. That's your distance. And of course, you're going to x and y because you're in a coordinate plane. So keep that in mind, because that's going to be some critical knowledge for you guys to know. All right, fun facts about the spin-off of the Pythagorean. We just proved it. We just proved it by manipulating the equation of a circle. So x and y, the coordinate xy, is going to become cosine sine. Cosine is going to be your x, and y is going to be your sine. Cosine is your x, sine is your y. It is also going to equal a and b. So x squared plus y squared equals r squared is the same as cosine squared plus sine squared equals 1. It's the same thing as a squared plus b squared equals c squared. So these are the exact same towards each other. Alright, so I want you to take a moment and demonstrate your skill of a 30, 60, 90 triangle. I want you to fill out each row by filling the appropriate boxes, and we will review. So pause the video and work out the whole entire box. Alright, so we know, let's do the first row. We know if a is 6 square root 3, a squared is going to be 108 because we have 6 and square root 3, and when you square 6 square root 3, you distribute the exponent of 2 into the square root and distribute that exponent of 2 to 6. So you're going to have 6 squared times, because square root 3 cancels out with the exponent of 2, you get 6 squared times 3, which gives you 108. Alright? Now because this is a 30-60 triangle, and because I already gave the hypotenuse to be 12, B is going to just be 6. And 6 squared is going to be 36. Now if I add 108 plus 36, I get 144. Alright, so let's look at the second row. Alright, so if a is 11 square root 3, we know that a squared is going to be 363. If b is 11, b squared is going to be 121. If we know that, well, I'm sorry, I'm tripping. So, why don't we not just add 363 plus 121? And when we add those two together, we get 484. Now we square root 484, we get 22. And that's just how you can remember it. Because remember, the hypotenuse is going to be twice the short leg. Then the longest leg is going to be short leg times the square root of 3. Alright, so now we got a 45 degree triangle. Now, you know without a doubt that 90 triangles have two of the same exact legs. So why don't you pause the video and try to figure this out on your own. Welcome back. So let's do the 45 degree triangle. So in the first row, we got a squared to be 81. So a is 9. And because we know that two of the legs are the same, so a and b are the same, we know a and b. And we know that c is just going to be 9 times the square root of 2. And we square both of that, we get 162. Or if you want to, you could just add 81 plus 81 to get 162. Alright, so let's look at the second row. So we know that A is going to be 2 because B is 2 and both legs are the same. So that means that B is going to be 4 and C is going to be 8 because 4 plus 4 is 8. But we square root both sides, it's going to, square root 8 is going to be 2 with the square root of 2. Alright, so let's do this last row. We know the last row has just 8 on the side. So if that's the case, A is going to be 8, and so x squared is going to be 64. B is going to have the same thing. If we add 64 plus 64, we get 128. And remember that C being the hypotenuse is going to be A, your radius, and your radius in this case is going to be 8 times the square root of 2. Mm-hmm. Just like that. Alright, these triangles that you are dealing with, these 45, degree triangle, and the 30/60 is going to be split up because 30 degrees triangle is going to have the longest leg in the x, but the 60-degree triangle, its longest leg is going to be in the y side of it. So keep that in mind. These are things to help you remember the ratio and stuff. All right, y'all. Let's discuss reference angle. So, at angles, reference angle is the measure of the smallest positive acute angle formed by the terminal side of the angle T and the horizontal axis. So all this is saying to you in translation is saying you trying to find the measure of the smallest positive angle, so quadrant 1, formed by all these other angles in quadrant 2, 3, and 4. So in quadrant 1, everything is there. In quadrant 2, you try to find the reference angles that goes back to um, quadrant 1. In quadrant 3 is the same thing. And in quadrant 4, so long story short, everything's gonna fall back into quadrant 1. All right, that's for you guys to remember. All right. By now, you should know all about the four quadrants on the coordinate plane. In quadrant 1, x and y is both positive. Quadrant 2, x is negative, y is positive. In quadrant 3, both are negative. In quadrant 4, y is negative. But before we continue, remember x and y is being replaced with cosine and sine. So cosine is your x value and sine is your y value. These are this is very critical. Without this particular piece, it is going to be next to impossible to get situated. So we're going to first work inside because we're going to find those reference angles. And then towards the end, we're going to work on the outside a little bit. All right. So you got 30, 45, 60. So in the other in quadrant 2, you got 150. But if you notice, it's the same color as my 30-degree triangle. So you have to just recall that. Have it mastered. All right. 45 degrees triangles. You're going to, I mean, this 135 is blue like my 45 degree. And then my 60 degree has my 120. 120 is the same color as 60. Hopefully now you begin to, see a little pattern because that goes back to the definition. It's this measure of the smallest acute angle, and which it refers to quadrant 1. Because quadrant 1, all your angles with the exception of 90 degrees is acute. Alright, so let's do quadrant 3 right quick. So you see 210 being red, so that's a connection to 30. 225 is blue, 45. 240 is green. You see 300, that's red, so that's 30. 315 is 45, and 330 is 60. Now, mathematically, I'm going to show you how this works mathematically. But I just want you to, see how we're going to work the inside. All right. So, as I told you in quadrant 1, your reference angle is pretty much the angles are here. Quadrant 2 is 180 minus your angle to get the reference angle. In quadrant 3, you have the angle minus 180. In quadrant 4, you have 360 minus the angle to get the reference. But going back to that unit circle, what did you notice about it with the colors? Think about it. Go, we about to get ready and do the work for it. All right. So when we get to the work, I am going to be worried about questions 2 to 4 because 2, 3, and 4, when I subtract them, it's all going to go back to quadrant 1. So keep that in mind because we're about to go ahead and work. Again, we just working the inside. Again, looking at this unit circle, what did you notice? All right, so let's build this up. So all the reference angles, about those 3 important numbers, is going to be within quadrant 1. So 30, 45, and 60 degrees is going to be the answers you are looking for when you're trying to find the reference angle. All right, so let's do 120. First and foremost, what quadrant is 120 in? If you said that 120 degrees is in quadrant 2, good job. Now to find the reference angle is going to be 180 minus that angle. And when we do that, we get 60 degrees for 120. So what I want you to do is work the rest of these out. Following what I just did. Again, how I got the 120, I subtracted 180 from the angle. And when I did that, I get 60. So you work ahead and go through all of these, determining if it's in quadrant 2, 3, and 4. And remember, your answers have to be out of 30, 45, or 60. All right, pause the video and try it out. All right, welcome back. So 135, you know, did you realize that was in quadrant 2? And you subtracted 180 from 135? If you did that, got 35, you are a legend. You are a skinny legend. 150. Let's do 150. 150, did you realize it was also in quadrant 2? And then you subtract 180 from 150? And you got that 30? Good job. What about 210? Did you realize that 210 is in quadrant 3? And you went 210 minus 180 to get 30? What about 225? You realize both, I'm sorry, 225 and 240 are still in quadrant 3. So did you subtract them both from 180? And you get 45 and 60 respectively. If you did that, you're doing really good. Nicely done. All right, so let's do the 300 to 330. And we know that that's in quadrant 4. So when you subtracted 360 minus 300, if you got 60, good job. And you subtracted 360 from 315, you got 45. You know you cool. If you subtracted 360 minus 330, you got 30. If you did this with no problem at all, you are all that and the bag of chips and the soda on the side. Okay? Nicely done. Again, we just build the inside of the unit circle. I know you guys probably gonna have questions about the 0 degrees, the 90 degrees, the 180 degrees, and the 270 degrees. They're also not going to be considered reference angles because reference angles are acute. And 90 degrees is not an acute angle, it's a right angle. But we are going to work on that at some point of the 6-part series. Probably less than 6, but as we're doing the unit circle, we are going to address those as well. All right, are we ready to proceed? So again, 30, 45, 60. And quadrant 2, 150 was 30, 135 was 45, 120 was 60. All right. And then you got 210 was 30, 225 was 45, 240 was 60. 300 was 30, 315 is 45, and 300 was 60. See how that all falls into place? Nicely done. All right, so look, I know I have taught you about reviewed the 30, 60, 90 triangle or the 45, 45 degree triangle. Those triangle properties are still going to play a part, but things are going to be slightly more different. So, the 30 and the 60-degree triangle is not going to be together, it's going to separate into their own triangle. So, you got the 30 has a triangle, 45 and 60, they all have their particular triangles. And I want you guys to be fully aware of their importance because this is how you build the unit circle. And now we're going to get ready to work on the outside of the unit circle as well. Because we just did the inside, now we're going to start working on the outside. All right? So I know you guys was asking about the 30-60 triangle, which I told you they separate. You was wondering if the long leg and the short leg is going to stay the same or they're going to flip around. Well, they are going to flip around. So let's look at the third degree first. The third degree has the long leg on the x-axis, which we consider that to be cosine, and then the short, well, the hypotenuse, which is your radius, and we know the measurement of radius is always going to be 1. But you notice that your hypotenuse is going to be 2. And your short leg is going to be half the hypotenuse, which is just 2. I mean 1. And we know that your short leg is the y, or is called your sine. All right? The 45-45 degree triangle, the 45 degree, sorry, the short and the long leg is both going to equal 1, and the hypotenuse is going to be the square root of 2. Now the 60 degree, the hypotenuse is still 2. Your short leg, it's changed because your short leg is right there. So your short leg in the 60-degree triangle becomes your x value or your cosine value. And then your long leg is your y, your sine value. Again, this is important as we build the unit circle. When I quiz you guys, I am going to quiz you on your ability to build that unit circle from the inside and the out. All right. So what I want us to do, I'm gonna give you the sides. The sides of this third degree triangle. And what I want you to do is to pause the video and give me the 3 basic trig ratios. I might ask you for the inverse. I will be asking them, but for this video on purpose and for the time, I'm going to ask you for the basic 3. So at this moment, I want you to pause the video and work these problems out. 3. Basic tree ratio. Pause video and let's get to work. Alright, welcome back. Let's see what you got. Did you get the sign to be opposite of the adjacent? But before we get to the answer, let me clarify something with you. So for the third degree triangle, I know you guys often like to say the trig ratio is opposite, hypotenuse, and adjacent. I know you guys like saying that a lot. And you're going to tell me sine is opposite over the hypotenuse. Cool, but remember, y is going to be here, x is going to be here, and your radius is your hypotenuse, so your r is going to be here. So let's not forget, those things are the same, but they have different terms. And now because you're doing the unit circle, you're not going to say opposite the, over the hypotenuse for sine, which you still can do, but you're going to have to dig a little bit deeper for testing purposes. So sine is going to be y over r, or opposite over hypotenuse, which is 1/2. Cosine is going to be x over r, or adjacent over hypotenuse, which is going to be square root 3 over 2. And tangent is going to be y over x. And we got square root 3 over 3. Now, I worked that problem out in the detail because we know when we first did tangent, we know we get 1 over square root 3. And we know this is forbidden to have a square root in the denominator, thus you rationalize. So multiply everything by square root of 3. And when you do that, you're going to get 3, the square root, square root of 3, 1 times square root of 3 over square root of 9. If we simplify that, we know the square root of 9 is going to be 3, or this rational number is going to be square root 3 in the numerator. And the 1 disappears because we know when we have a square root like 3, we're going to have a 1 square root 3. These are equivalent to each other. Alright? Now, you will be responsible for finding the other 3 trig ratios, but again, for the length of this video, I want you to practice with the basic 3. Alright, so for the 45 degrees, you're going to do the same thing. I give you the sides, because we know both sides are 1, and the hypotenuse is square root of 2. So what I want you to do, I want you to pause this video and give me those 3 basic trig ratios. All right. So let's see what you got. For sine, did you get 2 over square root of 2? At this moment, I'm not going to spend no more time going over that particular detail because we've been practicing rationalizing denominators. So we can move on. If you struggling to understand how we got square root 2 over 2, go back to the previous problem we just did and look at that and apply that same stuff we did in that previous to this to get sine, which is square root 2 over 2. And we got cosine to be square root 2 over 2. And then we got tangent to be just 1. All right. Good job if you got this all right. All right, let's do 60. Now remember, the short leg is going to be on the cosine side or x, and your long leg is going to be your y or sine value. So what I want you to do is do what we did with the other two, working on out. Pause the video and see what you're working with. Welcome back. Did you get sine to be square root 3 over 2? Did you get cosine to be 1 half? Did you get tangent to be the square root of 3? If you did that, you know you are a legend. Good job, legend. So what we just did, we just worked with these three angles, 30, 45, 60. And we know that those measurements are also going to be connected to all the other angles in the unit circle. So what we just did the trig ratio. And these are the values on the outside we just did. We just started working on the outside. We did the inside first, and we did the outside. Do not forget, it's going to be cosine as your x value, and sine is your y value. Ooh, I don't know why I put cosine y. I'm tripping. I mean, it's the same thing, but you're not allowed to use cosine y, I mean x on your test. All right, so we good on this? Now, here's what you got to worry about. Now, although you're going to get your reference angles here, and you're going to do the same thing you did with the triangles, but here's the thing with those trig ratios. Now you got to worry about which one's positive, which one's negative. So your cosine value in quadrant 2 is all going to be negative. So cosine is negative in quadrant 2. In quadrant 3, both cosine and sine are negative. And then in quadrant 4, sine is only negative. All right? It's just like I told you. You got to pay attention to your quadrants. Pay close attention to those quadrants when you're doing your trig ratios. I'm going to do one example for you, but that's as far as it's going to go. All right, so let's find cosine of 120. How are we going to achieve that? Well, for us to achieve such a thing, we need to find the reference angle. And we know that 120 is in quadrant 2, so it's going to be 180 minus 120, and that's going to be 60. So, with that being said, now we got to find cosine of 120. And we also know, because 120 is in quadrant 2, that cosine or your x value is going to be negative, and your y value sine is going to be positive. So with that being said, we know the long leg of a 60 degrees is square root of 3. We know that the short leg of the is going to be 1. And we know that the hypotenuse of 60 degrees is going to be double, which is going to be 2. Now, let us do our stuff. So, because we're in quadrant 2, and we know that cosine is our x value and sine is y, we could build everything up. Now, remember I told you about doing your trig ratio as opposite, adjacent, hypotenuse? Now, if I were you, I would stop saying it because now you're going to confuse yourself because now you got to think of x, y, and r to build your trig ratios. So now, because you are dealing with reference angles and you're trying to find the trig ratio of those reference angles, you want to think about what is positive or negative. So, saying opposite, adjacent, and hypotenuse to find your trig ratio is going to be confusing. But you could say that as cosine is going to be opposites. Well, cosine is adjacent, which we know is x, so it's going to be 1. But remember, because it's in quadrant 2, it's negative, so cosine is going to be that. And then your hypotenuse is going to be 2. That's going to always remain positive. Your rate is always positive. Well, in quadrant 2. So guess what? 1/2. Or you wanted to, you could have just said 1/2 and be like, oh, but it asked me for cosine, so that means that cosine is negative. So guess what? There we are. And guess what? There you are. All right? So before we close out, just look at your 120 because that's what we just did, right? And then we was asked to find cosine. Cosine is your x value, which is right here because cosine is negative in quadrant 2. Therefore, you get the 1/2. So